Solving quadratic equations with complex solutions. So for our first example, let's use the square root property to solve 2x minus 5 quantity squared equals negative 16. With our first step, let's isolate a perfect square term. And we have a perfect square term isolated already on the left-hand side for ours, so I don't really need to do anything for the first step. And now for the second step, we will square root both sides of the equation. And on the left side, the square root interacts with the squaring, and those are inverse operations, so we're left with 2x minus 5 equals plus or minus the square root of negative 16. Or 2x minus 5 equals plus or minus 4i. So remember the negative comes out of the radical, becomes an I, and we take the square root of 16 and get the 4. Now we will solve for x, which is the variable that we're using in this case. So I will add 5 to both sides of my equation and end up with 2x equals 5 plus or minus 4i. And then I will divide all my terms by 2, and I end up with x equals 5 halves plus or minus 2i. Remember, this is two solutions, 5 halves plus 2i and 5 halves minus 2i. For our second example, let's solve by completing the square. And our equation is 3x squared minus 9x plus 8 equals 0. And I chose one that was a little harder in case you've not seen one with all of these steps before. So remember, quadratics in standard form are ax squared plus bx plus c equals 0. So when I refer to a, I'm talking about the coefficient in front of x squared. When I refer to b, I'm referring to the coefficient of x, and c is the constant. So our first step, because our a is not 1, is to divide all terms by a. So we're going to divide everything by 3. And we end up with x squared minus 3x plus 8 thirds equals 0. Now we will move the constant to the right-hand side. So I will subtract 8 thirds from both sides, and I will end up with x squared minus 3x equals negative 8 thirds. And I do like to leave a space where that 8 thirds was, because I will use that in the next step. So now, for the third step, we will complete the square by adding b over 2a quantity squared to both sides. So I'm going back to my original a, b, and c from my original equation. So b is negative 9 over 2 times a is 3, and that quantity squared. That's what I add to both sides, because what I do to one side, I have to do to the other side in an equation for them to remain equal. So simplifying, we end up with x squared minus 3x plus 9 fourths equals negative 8 thirds plus 9 fourths. Then we will factor the left-hand side. And it will always factor, because of what we just did in step 3, as x plus b over 2a in parentheses squared. So I've already started that on my fourth step. I've got parentheses x plus b, remember, is negative 9 over 2 times a, which was 3, and close my parentheses squared, which equals, and in order to simplify my right-hand side, my negative 8 thirds plus 9 fourths, we do need a common denominator, and our lowest common denominator is 12. So the negative 8 thirds, I need to multiply my numerator by 4 to get negative 32 twelfths, plus my 9 fourths, I need to multiply my numerator by 3. 9 times 3 is 27. So my right-hand side becomes negative 32 twelfths plus 27 twelfths. Simplifying a little bit, we have x minus 3 halves quantity squared equals negative 5 twelfths. And this negative 3 halves is also, if we go back to step 2, where I had x squared minus 3x plus negative 9 over 2 quantity 3 times 3 quantity squared. If I take that b term that we had transformed by already dividing by a, that negative 3, and just divided it in half, negative 3 halves, that's what I have in this parenthesis. So x minus 3 halves quantity squared equals negative 5/12. And we'll continue on the next slide. So I'm going to rewrite that up here so we can see where we're starting from. Next step, use the square root property. And we will square root both sides of this equation. When we do that, on the left side I have x minus 3 halves equals plus or minus the square root of negative 5/12. So we can take the negative out, it becomes an I, so x minus 3 halves equals plus or minus I square root of 5/12. And we will leave it like that for now and come back to it later. Step 6, we will solve for x or get our variable by itself, and I will do that by adding 3 halves to both sides. We end up with x equals 3 halves plus or minus I times the square root of 5/12, which is a correct way to write my two answers, but often we don't like to leave fractions underneath the radical or have radicals in our denominators. So we're going to do something called rationalizing the denominator. So I'm going to take my square root of 5/12, and we can rewrite this as the square root of 5 over the square root of 12. We're going to take our denominator, which is square root of 12, and form a fraction with it. So square root of 12 over square root of 12, which is equivalent to the number 1. And I'm multiplying this by my square root of 5 over square root of 12. I can do this because when I multiply by 1, I'm not changing my value. When I do that, I get the square root of 60 over 12. And now I can simplify the square root of 60. The largest perfect square factor of 60 is 4. So I can rewrite the square root of 60 as the square root of 4 times 15 over 12. Or the square root of 4 times the square root of 15 over 12. Square root of 4 is 2. So now this is 2 radical 15 over 12. And now I can reduce by 2. So 2 divided by 2 is 1. 12 divided by 2 is 6, and we end up with square root of 15 over 6. So I can go back to the answer I wrote in step 6 and rewrite it as x equals 3 halves plus or minus I times the square root of 15 over 6. And again, remember this is two solutions. It's 3 halves plus I radical 15 over 6 and 3 halves minus I times the square root of 15 over 6. For our third example, let's look at solving 2x squared minus 5x plus 7 equals 0 using the quadratic formula. Remember, the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So our first step, we already have our equation in standard form, and we would need to put it in standard form if it weren't already like that. And now we're going to identify our a, b, and c. So our a is the coefficient of x squared, which is 2. Our b is the coefficient of x, which is negative 5. Our c is our constant, which is 7. And now we will take those values and substitute the values into the quadratic formula. So x equals the opposite of negative 5 plus or minus the square root of negative 5 quantity squared minus 4 times 2 times 7 all over 2 times 2. And notice I use parentheses when I substitute in, and that is the best way to substitute in values so that you don't make mistakes and become confused as to what operation we're doing. We will simplify this. So x equals 5 plus or minus the square root of 25 minus 56 all over 4, or x equals 5 plus or minus the square root of negative 31 over 4. I have a negative underneath the radical, so I'll bring it out as an I. We have 5 plus or minus I square root of 31 all over 4. And we could keep it like this, but with complex numbers, it's best to actually put it in proper complex number format. So I will separate my terms into 5/4 plus or minus the square root of 31 over 4 times I. And again, those are my two solutions.